Let's see formula of methanol and ethanol. This is methanol. This is ethanol. These are alcohols, hydroxyl group with alkyl group. Generally, alcohol is indicated by this formula. This is general formula of alcohols. This is alcohol and this is phenol. Which one is acidic? Alcohol or phenol? Which one is not? Why? This is today's lesson. That is acidity comparison between alcohol and phenol. In this lesson, we are going to learn acidity of alcohol and then acidity of phenol. So, let's begin. Firstly, let's try to know about acidity of alcohol. General formula of alcohol is this, which is liquid at normal state, that is ethanol. Generally, alcohol means ethanol. Now let's see whether ethanol is acidic or not. When this ethanol is dissolved in water, then let's see what happens. Here, electronegativity of oxygen is 3.5, hydrogen is 2.1. Here, electronegativity difference is quite high. So, this oxygen-hydrogen bond undergoes a heterolytic fission, and as a result, this alkoxide ion and proton might be formed. So, it may act as acid. Now let's see about the alkoxide ion. On one hand, the negative charge over oxygen doesn't disperse over the molecule. This negative charge doesn't spread over the molecule. That is why this ion attracts this proton very easily. On the other hand, alkyl group is a kind of electron donating group. Because of the presence of alkyl group, electron density, charge density over oxygen increases. That is why alkoxide ion has great attraction towards proton. So this proton again combines with this alkoxide ion to form this molecule, alcohol molecule. So this alkoxide ion is not stable. That is why alkoxide ion cannot remain free after donating proton. Because of its instability, alcohol cannot act as acid because alcohol actually cannot produce proton. Nevertheless, let's see what about alcohol. pH value of alcohol is 7.33, that is ethanol. From this value, we can say that alcohol is not acidic, but it is slightly basic in nature because this is a bit higher than neutral value. Now let's see why this is a bit basic in nature. Alcohol, oxygen contains two lone pairs of electrons. When this alcohol comes in contact with proton, then with this lone pair of electrons, alcohol can receive this proton to form this entity. Positive charge develops over oxygen. Actually, this positive charge shifted over this oxygen. But because of this positive charge, again this bond undergoes heterolytic fission and this hydrogen gets freed as proton. So this proton, and again alcohol is obtained. So alcohol has capacity to receive proton because of the presence of lone pairs of electrons. On account of this, pH value of alcohol is 7.33. So this is not acidic at all, but it has a little bit basic in nature. pH value is more than 7. So simply we can say that alcohol is not acid because it cannot produce proton. After releasing proton, alkoxide ion formed is unstable. It cannot form no resonance structures. Alkoxide ion again receives this proton to form this molecule, alcohol molecule. So alcohol is not acid. Now let's see acidity of phenol. Now the point is acidity of phenol. Let's see. Phenol, which is white crystalline solid. When phenol is dissolved in water, then here oxygen hydrogen bond undergoes heterolytic fission. Electronegativity of oxygen is 3.5, hydrogen 2.1. Because of the high electronegativity difference, in presence of water, oxygen hydrogen bond undergoes heterolytic fission and this hydrogen gets freed as proton. So here we get proton and the ion obtained is this phenoxide ion. Now this ion becomes stable through resonance. Because of its stability, this ion remains free after donating proton. Nevertheless, equilibrium is established because this is not a stronger acid. Its pH value is 5 to 7. This is slightly acidic, a bit lower than neutral value 7. Nevertheless, let's try to know its stable nature through resonance structures. Phenoxide ion, 3 pi bonds here. Pi bonding electrons move continuously through pi molecular orbital. Again, this carbon is sp2 hybridized carbon. We know sp hybridized carbon is more electronegative than sp2 hybridized carbon. sp2 hybridized carbon is more electronegative than sp3 hybridized carbon. So there are 2 points. One, pi bonding electrons move continuously through pi molecular orbitals. That is why phenyl group achieves electron withdrawing nature. Number 2, sp2 hybridized carbon is electronegative carbon. That is why these lone pair of electrons turn into bond pair of electrons and resonance structure is formed. This single bond turns into double bond, oxygen. Here, when these electrons come here, electrons repulsion is created. Because of this repulsion, these pi bonded electrons turn into lone pair of electrons. So this charge shifted at orthocarbon. Here double bond, here double bond. Another resonance structure is these lone pair of electrons turn into bond pair, and this bond pair of electrons turn into lone pair to form this resonance structure. Double bond, oxygen, here double bond, here double bond. Para-carbon gets electronically rich. Again, these lone pair of electrons turn into bond pair, and this bond pair of electrons turn into lone pair of electrons, and this entity is obtained. Oxygen, here double bond, here double bond is formed. This carbon, orthocarbon, gets electronically rich. Again, these lone pair of electrons turn into bond pair. Again, these bond pair of electrons turn into lone pair to form phenoxide ion again. Phenoxide ion, here double bond, double bond, double bond. Again, it happens. Again, this ion is formed from this ion. That is, repetition occurs. And finally, this is obtained again. These arrows are resonance arrows. That is, this ion changes to this ion step by step, and this ion turns into this ion step by step. Resonance hybrid can be drawn in this way. Oxygen partially negatively charged, partial double bond, partial bond, partially negatively charged. This orthocarbon, para-carbon becomes partially negatively charged. This orthocarbon becomes partially negatively charged. So, in phenoxide ion, charge over oxygen disperses throughout the molecule. As a result, charge density over oxygen decreases because this charge disperses over the molecule. That is why here charge density decreases. As a result, this proton doesn't feel great attraction towards this phenoxide ion. So, phenoxide ion gets stable and tendency to reverse reaction is decreased. That means phenol, after releasing proton, turns into phenoxide ion that becomes stable through resonance structures. So we can say that phenol is acidic in nature because phenol, after releasing proton, turns into phenoxide ion that becomes stable through resonance structures. That is, phenol is acidic in nature, though this is mildly acidic. But alcohol, from which alkoxide ion is formed, that is not stable alkoxide ion. It again combines with proton to form alcohol. Alkoxide ion cannot remain free after releasing proton. It combines with this proton again, and equilibrium is established almost on the left side. But in phenol, phenoxide ion get stable after releasing proton. So phenol is acidic in nature, but alcohol is not acidic compound. This is all about acidity comparison between alcohol and phenol. No more today. Thank you very much.